Hello there. Welcome to the IRM presentation webinar for quantitative risk management. Hopefully, everybody can see my screen and hear my voice. Great, thank you. I did get a couple of nods. We are expecting about a full house, actually, about 400 individuals, close to 400, but between 360 and 400 individuals who signed up for the webinar. And I see individuals trickling in slowly. So perhaps we'll give everybody a chance, to log in. We'll give them maybe another minute or two, and then we'll get the ball rolling. Great, welcome back. In the interest of time, let's just get the ball rolling on this, and let's get started. While we know individuals are trickling in, but we do have a quorum. We have triple-digit attendance at this point. So welcome again. Good afternoon to the United Kingdom, and good morning to Silicon Valley, California, which is where I am currently. Can you hear me? How about now, Deirdre? I just got a message from the sponsor saying there was some. Yes, I'm speaking right now. Are you able to hear me? Okay, wonderful. Thank you so much. I apologize for the technical difficulties. So anyhow, let's get started. This is quantitative risk management. It's an introduction, very high level, 30,000-foot view, if you will, of quantitative risk management as we do it at least in the United States, through IIPER, the International Institute of Professional Education and Research. And we're hoping to collaborate very closely with the IRM, the Institute of Risk Management, in the UK. So hopefully we will be able to, do something very interesting very shortly. So the agenda for today, we have a very full agenda. I'll give you a quick introduction to who I am in general, a little bit about the IIPER CQRM certification. The CQRM stands for Certified in Quantitative Risk Management. And instead of just giving you a laundry list of items that we cover, which is relatively painful, I will just show you hands-on applications. I think that, a picture, paints 1,000 words, if you will. And so we'll go through and illustrate how some of these quantitative methodologies could be applied. Again, very, very high level, tip of the iceberg. The CQRM courses that we run globally are 4 days, clearly. It's about 35 hours in total, and so I won't be able to do it justice in about an hour or so. So we'll just leave the Q&A, if possible, all the way towards the end, so that way I can actually be able to cover as much as I can. And the session is, of course, recorded, so feel free to be able to share the link to others who might be interested. So we'll start off giving you a quick little intro, some cartoons, if you will, of quantitative risk management methodologies. And the reason I do that is just to get everybody settled, and again, any latecomers, they won't miss the bulk of the demonstration. And then we'll jump into something called simulation, or Monte Carlo simulation. How do we do quantitative risk management? How simple it is, actually. If you can send somebody to the moon and back, right? You can send the Parker Solar Probe that literally touches the sun, least we can do is actually be able to do a little bit more quantitative methodologies with the computing power that we have currently. And we'll take a look at predictive modeling, forecasting. When we talk about risk, it's typically towards the future. We do look at the past where we do some backcasting, but literally, doing predictive into the future. Then decision analytics, how do you use these quantitative and qualitative methodologies to make better decisions? That's the whole point. How do you mitigate risk going forward? Looking at portfolios for risk hedging, enterprise risk management, where we're looking at heat maps, strategy maps. We're looking at KRIs and key risk indicators and so forth. We'll see how that works, how we mesh the qualitative and the quantitative methodologies together, project management and other different areas, depending on how much time we have. And like I said, we'll do Q&A towards the end. But if we have time, we can also jump into something called strategic real options, which is a really hot topic, which is the mitigation of risk. So flexibility to be able to navigate a very risky environment, if you will. And assuming we have time, I will try to carve out the last maybe 15 minutes prior to the Q&A to give you a quick overview of real-life cases and projects. And these are real projects that was done, by our organization, by our consultants and so forth. And I have about 300 slides to show. So clearly I can't cover all those in about 10, 15 minutes. So I'll just jump, fairly quickly across a few of these things to illustrate to you how the United States Department of Defense, the DoD, the federal government in the U.S. actually utilizes some of these methodologies. Companies like 3M, Airbus, Boeing, Intel, small companies, Johnson & Johnson, Motorola, all the way up to like the small mom and pop firms as well. And we'll also take a look at how, and that would be for industries, right, and applications, real life, cases, but also illustrate how we can do it for solution specific within the banking industry, Basel Accords and credit market operational liquidity risk in a bank or insurance company, biotechnology, COSO requirements, crisis management, what all these things are, high-tech IT, insurance, hedging, utility, M&A, pharmaceuticals, production firms, and how you'll be able to apply some of these methodologies across all industries, literally, when we have uncertainties. So I do apologize. I'm not able to. I tested this earlier to do a full screen, and there was some problems. So all I could do is actually, do it in the PowerPoint environment in this case. So hopefully you're able to see it on screen. I am Professor Dr. Johnathan Munn. I'm the chairman of IIPER, and we're located actually here in Silicon Valley in California. I'm also the CEO of Real Options Valuation Inc. And so the presentation is a mix between IPER and ROV. I'm wearing a dual hat type, situation. And again, we're, in California, Northern California, and we're, very, very interested to working with the IRM in the UK. Personally, I'm the creator of about 15 software applications doing quantitative risk simulation, forecasting, all the stuff that you've heard prior to this. Project management, enterprise risk management, and so forth. I've authored about 24 books. So in case you are interested in actually digging in a little bit deeper, feel free to, search me up on Amazon. And, as an author, you don't really make, money doing it unless you're, you write books like Harry Potter adventures, of course. So, if you get a copy of this, next time we meet, I'll buy you a pint. We'll call it even. So I'm also a professor at several universities globally, and I do travel a lot. I also hold a professorship with the United States Department of Defense. I do a lot of defense consulting work. We have a lot of patents pending, a lot of copyrighted intellectual property protection across all these different methodologies that you see. So instead of going and showing you, this quantitative analytics in general, I wanted to find something a little bit more specific. And so I'm going to, use the CQRM as an example. And the CQRM, again, is a certified in quantitative risk management. And it's accredited by, at least in the United States, it's AACSB, NASBA, Project Management Institute, all these guys. And in the UK, by IChemE, the Energy Institute, and hopefully very soon with the IRM as well. We are in approximately 300 plus universities as of the latest counts, and also about 300-400 multinational corporations globally using our methodology, having trained researchers using it, or having taught, or we accredit some of these universities as well. So what that means is if you do go through our, rigmarole, our, seminars and so forth, if you have a CPA, you will get 39 CPE credits. If you're a CFA, you get 39 CE credits. If you're a PMP, project management professional, you get 30 PDUs for that. If you're in all these other certifications or memberships, charters within these professional organizations, you get all the 24 CPDs and 30 CPD credits and so forth. So you're not, wasting your time too much. So like I mentioned, global acceptances, we did a seminar a couple months ago at the University of Hull in the UK, and it was quite successful. We're repeating that again this year, I believe, in somewhere in Spain and in Ghana. We're also doing it at Nottingham University, or University of Nottingham, coming soon in a couple months. So global acceptances, I won't bore you with the whole list. So a bunch of different companies are utilizing this. Okay, so let's talk about qualitative versus quantitative risk management or methodologies. To me, personally, qualitative and quantitative methodologies is a balance. Just like all things in life, a balance is needed. You cannot just go 100% qualitative, and neither can you 100% quantitative. If you go 100% qualitative, everything's subjective, and you don't have any numbers to make judgment calls. Making strategic decisions are very, very dangerous. You can draw heat maps all day. You can have red, yellows, and greens all over the place, but what does that tell you about the functioning of your company, of your projects, of your portfolios? So it's a little bit more difficult. But if you have the quantitative and purely quantitative, and you're making, decisions just based on, numbers without looking at the gut feel, without looking at the strategic overall, overarching methods, without looking at your experience personally, that's also a very dangerous type of environment because it's garbage in, garbage out. So to me, it is a balance, and a balance, just like in life, is required. So when we talk about risk, at least in the quantitative sense, right, there's risk and there's uncertainty. So you see this guy, towards the left, he's quite happy, he's putting his money in there, that is risk. He's putting his skin in the game, if that makes sense, as compared to a person just overlooking a roulette wheel and is turning around, and guess what? That is uncertainty if you don't put any money in. And so unless your skin is in the game, you do not have that risk. But you cannot have risk without uncertainty. You must first have uncertainty to have risk. By having risk, by definition, you have uncertainty. But you may have uncertainty without risk, if that makes sense. So when we talk about risk, we also, expressing the word uncertainty. And there's, of course, a whole slew of type of uncertainties out there. Political risk, developmental, natural, corporate, operational, environmental risk, market risk, and so forth. And we can actually quantify a lot of these things. Some things clearly cannot be quantified. That's where the qualitative piece comes in, and that's critical as well. So why do we bother with risk management? Things can go wrong, or things can go a lot better than expected. All right. So can we really predict the future? Can we look into this magic, ball and see, what the future actually holds? And the answer is, people have actually tried, experts have tried all the time. And so here's The Economist multiple years ago, and they had about 100 economists in a room, and they said, well, let's forecast, run all your predictive models, all the quantitative models that you guys have, all the fancy stuff, and let's see what comes out. And let's predict all prices. And the answer, of course, the headline is, we was wrong. Okay. So smartest people in the world, who are experts in that area, you got a little bit of a problem. Now, does the qualitative side help as well? And can experience help? The answer is, of course. Experience, gut feel is critical. That's why we call it experience. You've gone through it. You know what's going on. But here's a quote from, Captain Smith of the Titanic, right? So nothing's going to happen. It's the best vessel in the world. And, of course, we know what happened. But if you bring that up, 100 years later, we're talking about NASA, for example, again, smartest people in the world. And they say, you can't really have 100% risk-free type environment in a lot of cases. So you can't really guarantee a valve that does not leak 100% of the time. So anything's possible, but what you can do is determine what's the probability of that actually happening. What are the chances of, disaster actually looming? And so if that disaster actually occurs, what can you do about it? And that's the whole point. So historically, we've done things like a risk matrix. Another name for risk matrix might be like a heat map. I know, a lot of folks do this, like a red, orange, yellow. You might actually have a purple in there, a magenta, whatever, a huge color scale. And typically, you have an X and a Y axis, likelihood and impact, low, medium, high. You may have categories of 5 or 6 or 10, whatever you end up doing. and you multiply it out, then you get a KRI, a key risk index, a multiple, for example. And people try to make decisions with this, and it's fairly dangerous. You got to be extremely careful when you're using heat maps. You should not be just making strategic decisions, multi-million-dollar decisions, or even thousands of dollars doing this, because you just don't have enough information. It is not wrong. It is not incorrect. It just happens to be insufficient. It's just not enough information. So let's take this, okay, what is tried and true, let's enhance it. That's all we're doing. Let's just take what we've got and let's just make it better. So, historically, again, we've been using things like single point estimates. So we got $10, unit sales. You sell a pen is a $10 pen, and you sell 10 units, it's $100, and you take off all your costs, and your net revenue is $30, for example, just to simplify. We call that a single point estimate. You're saying you will get this, thou shalt get this value regardless of what happens. But in reality, not entirely, right? What's the probability of getting exactly $30.0000000 million? And the answer is close to 0% probability, okay? Because the area under a curve, under a probability distribution is your probability, but the area under a straight line is zero, close to zero. So we don't really want to do that. That's more of a traditional analysis. And so we push, the limits a little bit. We do something called scenario analysis. So we say, best case, worst case, if this goes up to $5, $10, $20, whatever happens. So you have three different cases, but which of these will actually occur? We don't really know either. You can also do what-if analysis, which is something called sensitivity analysis. What if this, gets perturbed, changes plus or minus 1%, plus or minus 1 unit? What happens? And surely you can do that. We call this a tornado analysis. So we say, highest bang for the buck, which of these variable inputs have the highest impact to the least impact, and you arrange it in a hierarchical structure, and therefore you get something called a tornado chart. So we'll say, okay, well, can we push the envelope just a little bit more, in fact, a lot more? And that's where we come in. This is where we take off. And we have this thing called the methodology, it's trademarked and patented methodology. It's called Integrated Risk Management Process, IRM, which, by the way, sounds like the Institute of Risk Management, which is great. So the Integrated Risk Management Process is a process methodology. If you look at the y-axis, everything says risk, has the word risk in there, risk identification, risk prediction. So identify what the risk is. So that's the qualitative piece where you do management screening, qualitative analysis. You say strategically, we're thinking of doing X, Y, and Z, A, B, C, and D. Then, let's go predict what the future may or may not hold. That's where the forecast prediction actually comes in. So in a couple minutes, I'll show you, models, fancy models like ARIMA models, GARCH models, time series models. Some of these are like Nobel Prize winning methodologies. I wish I came up with it. We wish we all came up with it, but we didn't, and we're just utilizing some of these methods to apply to quantitative risk. Then we do risk modeling. When I say model could be anything as simple as 1 + 1 = 2. You have inputs, you have outputs. What's the cost, what's the revenue, what's the timing, what's the schedule, and so forth. So we'll take a look at examples of project management in a bit. And then we can do risk analysis, which is a simulation. So instead of saying, here's a single point estimate, there is just one answer, one number. What we're doing is we're looking at thousands of different scenarios, if that makes sense. All right. So we're looking at thousands, even millions of scenarios, all possible outcomes that could occur, will occur, must occur. Okay. And so that's the risk analysis piece. We can always stop at step 4. However, if you do stop at step 4, you got a problem, because that's called risk analysis. What we're doing is risk management. You don't just analyze the risk, you got to manage those risks. So, but you cannot manage what you don't analyze. If you don't have a quantitative, structure of risk, you cannot manage something you don't know, in other words. So you kind of sort of need to get to know what it is to begin with, okay? And once you do, then you can do the risk management piece. That's why the risk analysis is critical. What's the probability that you will complete your project on time, on schedule? What's the probability there will be a, overburden of your budget, okay, and so forth. Then steps 5 and 6, again, if we have time, we can jump into real options. Real options is where we look at risk mitigation and risk hedging. So we're looking at, decision tree, strategy trees, option trees. We're looking at ways to reduce, hedge your risk, limit your downside, take advantage of the upside, and that has to do with flexibility. So that just, shows you what potential outcomes could actually occur. And then, of course, in step 7, you have something called a portfolio. So portfolio, just by definition, in the simplest form, is anything greater than one. So, for example, I love to collect pens, and therefore I have a whole portfolio of pens. I actually only have 5 nice pens, but it's a portfolio. If you have a bunch of stocks from various organizations, you have a portfolio of stocks. If you have a portfolio of projects or programs, things that you're actually running, a portfolio of companies and so forth. So how do we do resource optimization? How do you do project selection? How do you, given a budget of X millions of dollars and 50 different projects, which of these can you combine into optimal portfolios, and how do you choose them based on time constraints, risk constraints, budgetary constraints, and so forth? And step 8 is your report. Show your boss, explain it to the next door neighbor, if you will. And step 1 to 8 repeats itself. So never stop doing it until the project is to completion. So when the uncertainty becomes resolved, the uncertainty becomes known, the risk becomes known typically over the passage of time, action, and events. So you don't know what's going to happen. Wait a month, we'll find out. Action is you do research development, you test it, you do a proof of concept, right? And events, there's an earthquake, there's an event that actually occurs, a merger acquisition, there's war. So all these things get updated. Repeat the whole process again, right? 1 to 8, 1 to 8, 1 to 8. It's like a Monopoly board. You just keep going. The only difference is you don't get to stop at go and collect $200, but nonetheless, 1 to 8. So that's the quantitative methodology. Now, what I want to do is be able to just show you this stuff rather than showing you, here's the picture, here's what Monte Carlo is. I'll just illustrate some of these methodologies, and I see a lot more people have shown up, so this is perfect. And I'll illustrate this through the lens of the CQRM, the Certified Quantitative Risk Management. Pretty much tip of the iceberg of what you will potentially see in the course itself, in the whole environment, or when you do some training with us. And also, if you're interested, if you want to look at the slides, if you need to get additional information, you want to get some free videos and so forth, just go to our website, realoptionsvaluation.com, and everything is there for free. Just feel free to just download and knock yourself out. So what I will show you in a bit is I will illustrate for you, this decision analysis. I'll look at enterprise risk management, and we'll take a look at project management. And if we have time, which I'm hoping, I'll show you some consulting cases, from Department of Defense to 3M to Boeing to all these different companies I mentioned. So let's just see what we can do. But first, let me illustrate to you what it means by doing a simulation, right? Monte Carlo simulation. The screen is a little bit slow. I do apologize. But what you should be seeing is, the screen actually changing. All these numbers are actually changing. So we're actually doing something called a simulation. So we're generating, tens of thousands of potential outcomes. I know it's very difficult to see on the screen because of the slowness through the internet. So we're generating, perturbations, all possible outcomes, right? You look really smart doing this in front of your boss. You may not know what you're doing, but you're generating, simulation, millions of trials in this case. So let me just stop this real quick and illustrate to you one of the world's simplest model. Okay, and so you have an idea of what on earth this simulation methodology, quantitative risk management is all about. So on the left-hand side, hopefully, you can actually see something called a static model. Static model just means it doesn't change, right? It is static. We have revenues of $2 or $2 million, whatever you want to name this, and cost of $1, and therefore your income equals 2 minus 1. So I just put a simple equation there, $2 minus $1, D8 minus D9, right? And we can also see on the right-hand side, we have something called a dynamic model. Dynamic model in this case is a copy-paste job from the left side. So it's exactly the same thing, so 2 minus 1. The difference here is we have special names for these things. So anything that is an input, like a revenue or cost, I type in 2 and I type in 1, we call it input assumptions. Anything that has an equal sign, we call it an output forecast. So in any model, you have an input and you have an output, clearly. So what we're doing here is if the input is uncertain, okay, all we're doing is we're generating a new profile, in this case. A new profile is, think of it as, when you start, Word or PowerPoint, the first thing you do is you go file new, okay, because you got to start typing stuff. So a profile is, think of it as a new file. So I would click on new profile. This is a software tool that we produce called Risk Simulator, and there's something that you will learn in the CQRM itself. We do a lot of hands-on exercises and modeling. So I create a new profile, give it a name, okay. before coffee, because it is quite early in my time here in Silicon Valley. You can run a lot of different trials here, 1,000, 10,000, a million trials as you wish, and you would click OK in this case. So we created a profile where everything is stored. And let's just say revenue is an input assumption that we don't know what revenue is. We think it's going to be $2 million. We think it's $2. But here, we're just going to say we're not entirely sure. And so what I did on your screen, it's not going to come up yet. There we go. It's a little bit slow. I apologize. But we do have a couple hundred people sharing the screen. That's why. So I click on the set input assumption. Okay, I selected the cell, set input assumption. Input just means, I'm not sure what's going to happen. Show me what possible outcomes could occur. Here I can do a lot of probably distributions. If you're an engineer, you'll probably use like a whiteboard distribution, the mean time between failure of an inventory of a product, your turbine, your engine, and so forth. If you're in customer service, you can do a power distribution where we say mean time between waiting. How long does it, take for you to wait? If you're in HR, you can do a Poisson distribution, which means how many people you should be hiring, to make sure that we've got a 90% confidence that, people showing up in your bank will not have to wait, for example. Or you can use something very simple like a triangle. A triangle is like a triangle. Okay, you've got a minimum, most likely a max. So worst case scenario, most likely what you think you're going to get, maximum, the absolute highest you're going to get. So you can get these through subject matter experts from experience, gut feel. You have historical data. You have contemporaneous data, which means market, available data. You can look in the market. You can use historical data. Historically, we sell, ice cream. We sell hot dogs. A hot dog is like $2. We've sold it as low as $1.50, on special occasions, and definitely no more than $2.25. Reason for that is, you've got competition. You can't really, sell anything above that, for example. And all we got to do is click OK on here, and it says the cell green. I do the same thing for cost if I wanted to. And in this case, I can do something, I select cell G9 and click on set input assumption. This time I'll use a uniform distribution. I don't know what the shape is. I don't care. I know the minimum and maximum. I go to a store. I know the, cost of a hot dog is between 85 cents and $1.25, depending on the type of hot dog I have. So I click OK there. So those are the inputs. And on the output, it's income. So I select cell G10 and click on set output forecast. Give it a name, click OK. I can have as many inputs as I want, as many outputs as I want. And when I'm done, all I got to do is click on OK and click run in this case. And it says 1,000 of these iterations has been done. Right. So again, you can do 10,000, 100,000, a million, depending on the quality of the computer, how much storage you have, and so forth to store the data. So in this case, 2 minus 1 equals 1. If you're happy with 2 minus 1 equals 1, show your 2 minus 1. Life is good. You're done. However, what you've done is you've created 1,000 perturbations around that $2, 1,000 around that $1, and therefore you got 1,000, income values. You can look at some of the statistics. The mean value, is only 87 cents, 87.55 cents. Very difficult to see, I know. I apologize. But so your value expected, you think you're going to make $1, but in reality, on average, you're only making 87 cents in this case. So the value expected is not the same as the expected value in this case. In fact, I can do a 90% confidence interval. I'll type in 90 on here. I can't really zoom this in any bigger. I'm sorry. But you can actually see the blue line and the red line on here. I typed in 90, in the box, and it tells me that at 90% confidence is between 54 cents and $1.18 in this case. Okay, so we can say that there's a 5% chance you will make less than 54 cents. There's 5% chance you will exceed $1.18 in this case. So we can actually see what is my worst case scenario, what's my probability confidence interval. Okay, between certain, ranges. I can say that, if this is a project, I can say I've got a 95% probability of success, 98% chance that I will actually make more than, $0 or make more than 50 cents. If this is a schedule or a project management, for example, I can say, there's a 90% chance I'm going to complete this in 33 to 36 weeks. There's only a 5% chance that it will exceed 39 weeks and so forth, right? So you're getting, various ranges in this case. So that's just a very, very simple example of what you can actually do there. There are also a lot of different areas that you can apply this. This is like, for example, forecasting. I'll show you predictive models. I'm just going to open up this example right here, and I'm going to find a very, very simple data set. I'm going to zoom in as much as I can if possible. And here we see some historical data. Okay, and the historical data, the screen has not updated yet on your site. Oh, there we go. And we see some historical data here. And this is for, quarterly data points. So we see quarter 1, 2, 3, 4, again, in column C. And we see periods, there are 20 periods. So in other words, we've got 20 data points in this case. And we see sales values, right? So this is time series data. So time series data just means data follows time in a series. So January, February, March, revenues, cost, inflation, interest rates, whatever you want to use. You may have cross-sectional data. We can run that as well. Cross-sectional just means, one snapshot in time, right? And the data selected, this is where you would download from your historical archives or databases and so forth that you have. And in here, you can see a lot of forecasting methodologies that exist. So we can run ARIMAs, econometric models, that's what we do in class, fuzzy logic, neural networks, regressions, linear, nonlinear, limited dependent variable Markov chain, all this fancy schmancy stuff, stochastic processes, and so forth. But I'm just going to choose something super easy called time series analysis. When I pop that up, time series analysis, all I'm saying is, okay, run for me, a time series forecast. So the data selected, I just click that one button and say the data is in quarters, and please predict for me 10, periods. You can predict as many periods as you want. It's up to you. But the further out you go, the higher the level of uncertainty, and therefore least, certain, if you will. So in this case, I'm just going to click OK. It goes out there, thinks, and it generates a set of results for me. And here you would see a result. So all I did was literally just click OK. So it ran, Holt-Winter's multiplicative model, whatever that means, right? 2 dead people, 2 dead econometricians. But nonetheless, what it did was generate for me a predictive model. And you will see here, on the chart, the blue lines or the blue dots, we've got 20 different dots. That's your actual or historical data points. Okay, we see a trend, going upwards, and you also see some seasonality. Things go up and down and up and down. So this could be, for example, ski tickets. You sell more ski tickets in the wintertime than you do in the summer, and guess what? You're going to repeat that again next winter. So that's seasonality in this case. That's a trend. That's your historical data. And then look at the red dots or the red lines. That's your forecast. So I asked it to forecast previously 10 data points going forward. But prior to asking it to forecast, forward-looking, so casting a net into the future, what this does is it did something called a backcast. It did something called backfitting. So if you have data, and guess what? All companies have data. It's either you've got way too much data or not enough data, but you've got some data. In this case, we do a backfitting. We see which of these models, it tested about 8 different methodologies to see which provides the best fit possible. And whatever the best fit is, it brings it forward into the future. And you see the trend and you see the seasonality as well. So we see the actual values for 20 periods. Here's the forecast fitting. We do a back fitting. Then we forecast this out for the next 10 periods. And so pretty easy to use. And depending on the type of data that you have, you might be able to run a neural network method, a stochastic process if you're trying to do like stock prices for whatever reason, and all these other methodologies, families of methodologies. So what it does is it generates for you a forecast by just clicking a button. How accurate is this? We can look at the error measurements. It's plus or minus 4.5%. For some people, it's good enough. Good enough for government work, as they say. Mean absolute deviation plus or minus $53. So if you're forecasting $2,000-$3,000, plus or minus $53, that's your tolerance. It's up to you if you feel like that's decent. If not, get additional data. We can run regression, econometric models, all these other fancy type methodologies as appropriate. So in here, notice that everything is green. What that means is I can actually run simulations on this. So these green values are actually going to perturb. They are going to change in this case. So instead of giving you a single point estimate, okay, all these green cells are going to be probability distributions. So these will no longer be a single point estimate, but it is a probability distribution. Okay. Again, the screen is a little bit slow to update, but just imagine the green cells actually changing and perturbing. There we go. And all of these things are distributions. So I'm no longer giving you single point estimates, but I'm providing you a range of potential outcomes in this case, right? So we can do forecasting on here. We can do a lot of different analytics, quantitative analytics, like sensitivity analysis, for example. Let me open up a simple model here. This is a, cash flow model. It could be any type of model. Again, 1 + 1 = 2 is a model. So you can have the world's most, basic model. You can have the world's most advanced methodology and that you calculate. It really doesn't matter. Methodologies apply similarly. So in this case, it's a financial model, and the key to this whole calculation happens to be the net present value, which means like the answer, if you will, right? The bottom line. So we select this bottom line cell, right? And all I need to do is click on tornado analysis. And notice we've got a lot of analytical tools. You can do probability distributions here. What's the probability something will occur? You can do, hypothesis testing. You can do seasonality tests, segmentation, sensitivity, structural tests, all these different things. But I'm just going to run something called tornado analysis. And very quickly, it generated for me a, tornado set of results. And notice that this is nothing but a sensitivity table. So it tells you that your capital investment on here has the highest impact, tax rate has the second impact, price is third impact, and so forth. Which drives or moves the needle of your project the most, right? As compared to, in the entire model, you may have a lot of different inputs. What is most critical? Okay, you rank it from highest to lowest in this case. So that's what sensitivity, tornado, dynamic analysis does for you, identifies your critical success factors for you. And from here, you can decide, well, do we truncate, do we reduce the risk by maybe having a better contractual agreement? Revisit the vendor, do whatever you have to do to mitigate that risk. But you've identified the main sources of risk that perturbs, that destroys your project potentially, or make it successful, either way. And you want to be able to pick that and identify that. So you can have a huge tornado analysis. And, an example I did was with Saudi Aramco and, in Saudi Arabia. And those guys were looking at piping, pipelines for their oil and gas, delivery system. And we're looking at a couple thousand miles piping. And it's either comparing that or analysis of alternatives, looking at potentially trucking versus, rail versus using ships, okay, to actually transport raw materials and so forth. And the main criticism that they had internally was that price of steel was extremely high. Price of steel is too high. We can't afford to, build this pipeline and all this good stuff. And they kept obsessing about price of steel for 6 months. So when I went in there, did a consulting work for them, ran a tornado, and showed them that price of steel was way down there. In fact, the critical one was, guess what? The price of the land, was the insurance, was actually the development, and so forth. That completely changed the whole discussion around to say, we're no longer going to talk about price of steel because we just proved that it was relatively, irrelevant in this case, right? So you can actually have a very interesting type of conversations around some of these methodologies. I'll open up another example here, and then I'll show you project management and other things as well. So let me zoom in as much as I can here to maybe 200%. Okay, so here we've got something called portfolio. Again, portfolio is anything that is greater than 1. So in this case, I've got 12 different projects. I've got the expected net present value, the profitability, the cost, whether it's a mergers acquisition, whether this is a capital implementation, it costs you a lot of money to spend on this. It costs you $1.7 billion, and the net present value after the cost, after net of everything, is still a positive $458 million. That's still pretty profitable. I've got some risk in here, which we obtain from running the simulations. You get the, probability of the risk itself, or, the volatility. And if I were to, in my company, invest in all of these things, it will cost me $8.2 million or billion dollars. So it's nothing but some product. So the cost is 1.7 times 1 plus the 859 million times 1. So the ones and zeros here are your selection. On column J, the one in blue, tells you, go, no go decision. Do I do this? Do I not do this? If I do all of them, it will be 12 projects, and it will cost me $8.1 billion or million of dollars. I only have 12 different projects here. But imagine, if you only have, say, 3 projects, A, B, and C, the number of portfolios you can create would be A only, B only, C only, A and B, A and C, B and C. You can also, by definition, do all A, B, and C. So there's literally 6 plus 1, or 6, types of permutations. And that is just because of 3 different projects, A, B, and C. So 3 factorial, 3 times 2 times 1 is 6. If I have 12 of these, it is actually a factorial of 12. which means 12 times 11 times 10 times 9 times 8. So the number of possible potential portfolios you can create, 1 only, 2 only, 1 and 3, 1 and 5, 1, 3 and 5, is 479 million potential outcomes. So you do not want to do this by hand, if you will. So what if you have a budget constraint of, I only have $4 million this year to spend, right? That's my discretionary investment. And my boss, for whatever reason, says choose the best 6, no more than 6. You can do 3 or 4 or 5, but definitely 6 or less. How do you choose this? You may add additional constraints on here, limitations such as full-time employees, FTEs. I only have 25 managers, 36 engineers. How do I task them so that I don't have to go start hiring additional people? What's the probability of actually, having an additional 10% buffer in terms of dollar amount or completion on time? Which of these projects do I choose? You can add any and all of these complications, if you will, and we can show you that in a few minutes. And what I do here is run something called optimization. And again, there's a whole bunch of methodologies I won't bore you with. And the methodologies, you're going to learn all that in class. All I did was I pulled up the optimization. Okay, optimization just means optimize to find the best combination, the best thing possible. And again, your screen might be a little slow, but you should be able to see, the blue cells twitching or changing slightly. And outcomes, here's my results that you actually see. And I will click on replace in a bit. So we'll just wait for your screens to actually catch up. And what you should be able to see in this case is, there we go. Maybe it's a little bit slow. What you will see is all the combinations and permutations that could occur, but we don't use all 476 million of those permutations because it would take too long. What we do is we find heuristics and algorithms to actually make this work. And what you would end up seeing is what I see on my screen here, 6 projects. And I spent a total of $3.7 million, okay, under my budget of $4 million. And the best combinations I should choose would be Project 1. You see a 1 here. Project 4, Project 6, Project 8, Project 11, and Project 12. So that, would be my best 6 that I would, select, given my budget constraint, time constraint, schedule constraint, employee constraints, and, any other restrictions that you want to be able to put in or impose into the calculation, into the model itself. Okay, so that's portfolio. So all of these things are quantitative, is all doable. And now we can actually apply it to anything that you want. So here, for example, I'm going to show you another tool here. I'm going to wait for the screen share to update real quick. All right. The system I'm going to show you next is something called PEAT, or Project Economic Analysis Tool. Let me try to refresh the screen. Let's see if that'll work. I will share the screen yet again. It's a tad slow because I'm also looking at the screen itself, and it is still on my Microsoft Excel. Let's see if, there we go. Took a little bit, sorry. On the bottom screen, you can actually see a complex task model. And what that is actually a project management model. So you can create multiple projects, project A, B, C, D, E, as many as you wish, and you can create those tasks, right? And creating those tasks is just drawing boxes. You click on a button, and it just allows you to create those tasks. So task 1 goes to task 2. Task 2 breaks into 5 and 6. So think of it now as a systems dynamic type of situation where things break up in parallel. 6 begets 9, and 5 goes to 11. But 9 also goes to 11, and 11 goes and joins back into task number 14 in this case. So you can draw this, and I'll show you how to draw that in a minute. And you can go into schedule and cost analysis, and I can put in, fixed costs, scheduling in weeks, variable costs in weeks. I can have minimum, most likely, and maximum values for costs, for fixed costs, for scheduling. And what I can do is replicate this across, multiple projects, and be able to look at the entire portfolio all at once. So project A takes X dollars, takes Y number of months, and everything is all charted in this case. I can actually run apply analytics, which is like a tornado analysis, and I can run a simulation as well. So here I just ran something relatively quickly, and let's get the results. There we go. And you can actually see the tornado analysis on here, which is, again, the bang for the buck. You can see which of these inputs, is it task 5, is it task 6, is it task 7, that actually, kills you? Is it task 9 or task 13 that actually has that issue for you? You can actually look at scenarios. We can look at simulation. So in this case, would be project A all the way to project E. So different ways of implementing it. This could be various projects, or could be different ways of implementing the same project, right? Different scenarios. It's up to you. So in here, project cost is going to be $7.9 million to complete. We can actually do a left tail, for example. So anything to the left, and I'll do a percentile of 99%. So the 99% as you see on your screen that's going to pop up momentarily is a vertical line. And you will be able to see that the 99% says 8.5 million approximately, rounded. So on the expected value, on average, you are saying single point estimate is going to cost $8 million. But guess what? 99% of the time, you're going to say, you will not exceed 8.5 million. So you need that additional $500,000 as buffer. To say 99, only a 1% probability, extreme outlier, extreme situation or scenario that you will have, anything above that $8.5 million. So that provides you a buffer, provides you a quantitative way of measuring, in this case, the project. You can also do the same thing for schedule. So it might take 193 weeks or days that you will complete. But if I really like my job and I put a 99% confidence or 99%, rate here, instead of 193 days, I will ask for 209 or 210 days or 210 weeks. So that's my additional buffer of like additional 17 days or 17 weeks, so that I know, given all the uncertainties that may occur in each of these projects, okay, so plus or minus, task 1 might take between a week and 3 weeks. Task 2 might take between 2 weeks and 2.5 weeks. Task 9 might take between 9 and 10 weeks. I'm including all possible outcomes, and I'm running all these, and I can determine, what is the probability in totality that it will take me, that will cost me, and so forth. And also, it generates for you this red line that you can see here. That is your critical path. So it tells you that, what's going to kill you is task 1, 3, 8, 10, 13 to 14. So if you try to mitigate your risk, those are the tasks that you should be spending time on, that you should be analyzing, and you should, try to mitigate the risk of the uncertainty on those things. And again, this is extremely easy to do. You can just add another project in here. Okay, I just added. And all I'm doing is I'm creating this, click on this, there's a button, and I go, oh, that's task 1. Becomes task 2, becomes task 3. I move this up here, task 2 again, becomes task 4. And task 4, I click another button, task 5. And I can connect these two things and just link those tasks. And I've just created myself a simple task model. Create a model, and now I can input in the minimum, most likely maximum values, for schedule, for costs, variable, weekly costs, overrun assumptions, maybe a probability of success, if I wanted to, and set it up and run the same analysis that you saw previously. Okay. You can also apply this to enterprise risk management, or ERM. And ERM is the traditional methodology of doing qualitative risk. So in here, you can actually see this KRI picture. In here, I've got a 1 to 10, on impact and on frequency, so frequency and severity, if you will. You can always change it if you don't like severity, because it's a negative connotation. If you don't like frequency, you can always change the text to whatever you want. In here, I just use the standard, frequency and severity based on COSO requirements, IRM requirements, and so forth. You can put in risk groups. I can put in divisions, so Middle East divisions. I can put in, different departments. I can do something called GOPAD, which stands for geography, it stands for operations, products, activity, department. So you can go as granular as you want. You can assign certain risks to a certain department, certain individuals, certain operations, certain geography, activities, and so forth. You can create your own risk category or use our inventory of risk, compliance risk, cost risk, credit risk, pricing, technical, supply, or whatever. You can add in risk managers. You can, that's just your database. And once you're done with that, we go to something that is very familiar to a lot of people, which is your risk register. You can create as many risk registers as you wish. On the right-hand side, top right-hand side, you saw, you see the highlighted project, tab there. And you can add in as many registers as you want. These are all risk elements. So we can say, this is rework. So scope creep, continual enhancement, your client keeps asking for the same thing or keep changing their minds. You can put diversifiable risk, residual risk, so likelihood and impact 1 to 10 or 1 to 5. You can do a voting capability. You can actually have like 10 people to vote for this, or you can just put your values in there from 1 to 10. It's a categorical number, right? So it's an integer that you put in. You may put in risk controls. So if this is a fire risk, you might actually say put in sprinklers. You might do, something else, fire training. You may, do other things as well. Buy insurance, fire insurance, for example. You can put in things like diversifiable risk. How much does it cost you if the whole entire building burns down? It's going to cost you $155, million. The maximum is 175. Minimum is 120, whatever. You can put ranges in here, and you will see the color coding that comes up, and that's your data entry. Once you're done with that, typically you look at dashboards, total corporate risk. So now we're taking the qualitative risk element, and now we're quantifying it just a little bit more, pushing the envelope. So you can see corporate risk. You can look at the risk maps counts. This is, again, your you got to be a little bit careful with the heat maps because it's more for risk visualization. Okay, the density of the risk, the collection of where do you have a lot more reds than you have greens or whatever, but it's not really useful for just purely decision making. For decision making, you want to go in and dig in a little bit deeper in all this. So what is my risk exposure for each of these, various departments, divisions, geography, products, and so forth? What's my risk taxonomy, my risk inventory? So you can go through all these different things. Risk events. So again, I'm showing you a very high level, tip of the iceberg. Risk events is where you can actually keep a diary, running diary of all the risk events that actually occur. And you can look at, customizing the charts, the tables, the results in here. Risk engagement diagrams, risk controls, risk mitigation. You can do a risk mitigation analysis whereby you're saying, okay, if you have a training or a new type of equipment, prior to the equipment and after the equipment, was there statistical significant difference among these things? Was that investment good enough? You do a proof of concept before you roll it out across, 50 different organizations or 50 different, plants, if you will. So you do a POC, proof of concept, test it out, and we prove it whether or not it is successful. You can run simulations on this. You can do the tornado sensitivity. You can do portfolios. All of these things are applicable as well. So you're pushing the envelope. Or you might have a situation where you're doing capital investments for a company. And you may have multiple projects, project 1 all the way to, project 50, whatever. And each of these projects will have its own revenues, costs, capital expenditures, and all these different things. And all you need to do is enter the data here. Okay, it will calculate your cash flows for you, provide economic results like net present value, internal rate of return, the standard 7 metrics that you use in Finance 101. So modify internal rate of return. Everything's all automated for you, which is really nice. And then you go to the portfolio, and the portfolio will just roll everything up for you nicely. It will show you, how project 1 versus project 2, 3, all the way to 10 actually stack up to one another. So we're doing quantitative risk. This includes uncertainty because now we can come in here, run a scenario analysis. What would happen if my interest rates go up from 20 to 38%? What would happen if my revenues go up or go down? So you can actually see that your profitability becomes negative, red. Your profitability is very, successful here. So if your tax rates go up, guess what you need to do is probably up your prices if you can, right? So a lot of different combinations, for you to actually go through. And I do apologize because this is a lot of material, and I am calling from Silicon Valley, so it might be a little scratchy. Technology is trying to catch up. I'm looking at a screen and it takes probably around 10 seconds before it actually shows up in your end. That's why we have live sessions, right? So it's a lot more, interactive, if you will. So I do apologize for that. I thank you for your grace and your patience. So you can do scenarios. We can do tornado analysis. And the tornado analysis, again, is your highest impact to the least amount of impact, right? So there's a whole bunch of different applications here. We run simulations, kind of like what we saw previously. So high, medium, low, what's the probability of an event actually occurring? What's the probability my profitability will be positive? You go overlay these things. You can compare across multiple programs. I can look at Project 1 versus Project 2 versus Project 5. I can see how the spread is, what is the uncertainty across all of these. I can look at analysis of alternatives. I can look at not just single point estimate, but the probabilities, the volatilities, the uncertainties, the risks across multiple things all at once. I can actually do options valuation, which again, if we have time, we'll take a look at. Portfolio optimization. So I can actually run a portfolio and say, here's an example of a portfolio for a budget. If my budget is between $2 million and $4 million with a step size of $500,000, so which projects do I, invest in? Can I invest in if I only have $2 million? If I have 2.5, 3, 3.5, $4 million, and so forth. So I can run that and I generate something called an efficient frontier, the most efficient portfolio I can. Another name for that is the Markowitz efficient frontier, after Harry Markowitz, the guy who got a Nobel Prize for this. Indicates that these are the combinations that you would, that they would recommend based on the analytics, based on the input, based on the risk and the uncertainty. Given all the uncertainties that you have, these will be the best. This is the best that you should be able to do and that you can do, if that makes sense. So, if you have $2 million, you would execute these programs. If you have $2.5 million, I would, take option 5, kill it, save the money, okay, and put it into option 2, which is a little bit more expensive. For example, if I have $3 million, this is what I would invest in, and so forth. You can do the same thing in terms of, other types of, inputs as well, not just a financial. It could be a non-economic type environment. So in here, there's an example of a non-economic environment where we can have value to society. You can put in any of these values, okay? Value to society, management assumptions, your gut feel, strategic value. You can add in anything that you wish, competitive effects and so forth. Maybe that's really critical for you. And you can completely bypass the financial piece if you don't want to, if that's not what you do, okay? So lots and lots of applications. And I know we really don't have too much time, but let me show you a couple of sample cases, hopefully that will whet your appetite a little bit and get you thinking. I know I'm going to cut into Q&A time. I think everybody's in agreement. It's probably worth our time to take a look at some of these methodologies. And if you have any additional questions after this, feel free to just contact us directly. It's not a problem, because I am trying to satisfy, 200 plus people who actually signed up, 300 plus people who actually signed up for the webinar. And so instead of answering very, very specific question to, one individual in a specific industry with a specific problem, I'm trying to get generic and high level, if you allow me to do that. So there are hundreds of free cases, literally hundreds of them on the website. So all you got to do is go there and go find the one that makes sense for you. This IT information, oil and gas, pharmaceutical, Navy applications, Boeing example of their global Earth observation systems of the satellites, valuing employee stock options if you're in accounting, stochastic optimization, alternate uses of real estate, credit risk, market risk applications, and so forth and so on. So, just go there. It's all free. It's all available. Just, enjoy. So a couple of quick little examples. Here's the U.S. Department of Defense, air, C4I, space, submarine, surface marine. So if you can just imagine, United States Department of Defense, small little thing that they have called risk. So clearly a lot of, risk, a lot of uncertainties involved. In fact, they have a lot of requirements that says you must look at some of the stuff that I've already shown you previously. In the next slide here, there are rules and laws out there that says you must look at risk and returns. You must look at investments within a portfolio. You must look at everything analytically. You must do all these different things. So similarly, we apply portfolio optimization, and we are able to do things like military score, return on investment, tactical score. So the military individuals, the commanders on the ground, the boots on the ground will be able to score every one of these technology by, a ranking score, and be able to do, we run that optimization. Given the budget of $150 million every year for this specific squadron, a specific tactical group, they have 150 things on their wish list. Which of these combinations, project selection, would you go for? You can actually create strategy tree, which we didn't have time to show you, but we have like a strategy decision tree, which is a dynamic decision tree. You're running simulations on the decision tree and on a option tree to look at various strategies that you would execute this. This is the U.S. Navy CCOPS program, cryptologic carry-on program that we executed. The case is actually also on the website if you want to, look it up. So do you go remote to shore? Do you do a direct support? You actually have this, high-tech technology, which is a next generation, radar system as a direct support on the permanent ship, or do you put it on the remote to shore, which means there's a building somewhere, a couple thousand miles away, and you send signals via satellite, and individuals will do the analysis and tell you, friend or foe. Or you do actually have those individuals on the ships themselves, which would increase the efficiency and the speed of information. So, how does that actually work for you? There's also a bunch of other applications here. This is an example of like FedEx and 3M. Okay, 3M has like hundreds, if not thousands, of different products out there. And the one that we always know that we talk about is sticky notes, but clearly they have a lot more than sticky notes. And so their issue was to figure out, how efficient, what's the probability I would actually, or 3M would be able to hit their budget. So they go to Wall Street and they promise, our earnings per share is X, cents per share or X dollars per share. And in order to actually meet that criteria to be able to hit that target, they have to hit it, specific sales or specific income or specific revenue stream for the next, foreseeable 5 years, 10 years, and so forth. So we're doing predictive analysis. So how much money do you put in for research and development? With, 0.75 billion, $1 billion, 1.7 billion, how much do you put in? And given that budget, where do we park it? Which of these programs do we invest in? Such that, we have a probability of actually exceeding expectations of Wall Street. The last thing you want to do is be able to tell Wall Street, we're going to hit this target, and then you miss it. There's going to be huge overreaction and ramifications. So you want to make sure that you've got a, 99%, 95% chance of actually exceeding where you are. And so, given that, you present to the board and you say, okay, if you give somebody, $700,000 or $700 million for the next 5 years, the probability of exceeding what you promised to Wall Street is 60%. If you provide $1.2, $1.3 billion in terms of research and development, we can do all these other areas, these different products that potentially could be the next, big thing. How much should you be spending, and where should you put these values in? And so the other thing that some of these high-tech manufacturing that Motorola has also is that they've got a lot of revenues, a lot of historical data. They've got forecasts of the sales, actual, productivity, how much research and development that they put in. So we can run econometric models. So when I say econometrics, think of it as, like regression modeling. Regression modeling regression analysis is the firstborn of econometrics. And clearly econometrics is a lot of, it's a big family. So a lot more advanced analytical pieces. But if it suits your, paradigm, just think of modeling in terms of a regression. So we're trying to figure out, the velocity at which you obtain the values, what is the net productivity that you obtain, risk-adjusted return on capital. We can do all that for these companies. We've done projects for Goodyear, Budweiser. I love Budweiser because it's a beer company. We always get free beer every time we show up. Timken, which is an industrial production, they do steel manufacturing, bearings, and so forth. Goodyear tires, and so forth. For Timken, what we did was try to match up the uncertainty, the risk. This you can actually see things going up and down. Stock prices, they're also looking at price of steel, price of their input, fuel prices, and so forth, and trying to be able to predict and be able to hedge their steel prices. And so when we do the options piece, the real options piece, we're able to, do things like option to abandon, option to, a sequential option, doing things in phases, phase 1, 2, phase 3, phase 4. You can't go to phase 3 without first doing phase 2. You have an option to expand. You have the option to abandon or walk away. You also have an option to switch, like a switching option. So instead of having a single, let's say vendor, we have multiple vendors at the same time. And these vendors are located globally. So the prices, tend to change from one location to the other. And so you have the option to actually switch vendors to something that's a little bit cheaper, faster, and quicker. So you take advantage of the price savings. We do a lot of forecasting in terms of econometric forecasts, predicting, the prices for these guys. And price of the inputs is what kills them. It's their main risk. And so predictive models is their critical piece. There's also, for Budweiser, we did quality control and testing. So quality control in this case, they've got, again, a lot of historical data. We're looking at major tanks of, making the process of making, beer. And so what they've done in the past was testing every single tank every single week. It's 100% quality control, but it's extremely expensive. It costs them hundreds of millions of dollars globally per year. So we're able to identify the tolerance level, okay, at 6 sigma. In fact, these guys go up to like 8 sigma and 9 sigma, which is even more, high level tolerance. They want to have a perfect, close to perfect, quality control. We're able to identify, how many weeks you can actually skip, how many of these things are predictive of what potential, errors could actually occur, and be able to, literally save them millions of dollars in this case. GE Asia Financial Economic Analysis, we do something called Asset Liability Management, ALM. So for GE in Asia, the housing market, interest rates, inflation rate is what actually kills these guys. So imagine if you have a home mortgage and interest rate suddenly, drops significantly. What a lot of people will end up doing is they refinance. They will go to another bank, Bank B, borrow the same amount of money, pay off Bank A, and Bank A suddenly just lost all of their assets, immediately. And it's not good for business. So what happens is they have immunization, and we forecast with predictors. We optimize the hedging. So something called delta zero hedging, which means delta is the difference. So there's zero difference. You're immunizing things perfectly. Same situation could be said for companies like Southwest Airlines in the United States, where, the number one most critical cost for an airline is actually jet fuel, because jet fuel is very expensive and there's huge risk, huge uncertainty because prices just fluctuate like crazy. And so what they do is they hedge their fuel prices by going long in the fuel market into the futures market. And so how much of that should you do? If you overextend yourself, you're wasting money, or you potentially could face losses. If you if you under hedge yourself, you're also losing money potentially. So there's an optimal level at which you can, do the portfolio. And that's what some of these things are. Intel, Northrop Grumman, Saudi Aramco, a lot of these different individual companies, we're looking at strategies. We're looking at options, in this case, real options. How do you mitigate your downside? How do you take advantage of the upside? Okay, you have the option to abandon. You have the option to switch. You have a sequential option. So you can apply all of these analytics. This is a DRAM price extrapolation of forecasts and predictive risk-based forecasts for Intel to look at, prices actually decreasing significantly. In financial engineering, if you're in public finance or you're in any other type of finance, we do have, and if you're in public finance, we do have another module which we don't have time for, and that is knowledge value added, where we're looking at, for government type organizations where we don't have, or nonprofit organizations where we don't really have something called revenue, quote unquote, like the Department of Defense or the government does not really have revenue. They do have taxes, but they don't sell a product, but they definitely have cost expenditures. So the question is, how would you analyze some of these? And so we'll see how that works. Financial engineering, you can actually do a predictive model. If you're doing, public accounting, for example, and you're looking at, how much should this company actually be able to expense in terms of option expenditures for the futures, for the forwards. They have all these type of exotic instruments. They've got, option embedded instruments in a contract. So they say, we're going to acquire a company, but we're not going to buy you completely. We're going to buy 20% of your equity for, $5 million with an option to purchase the remaining 80% for, another $10 million in the next 3 years, whatever. How do you value something like that, right? How do you value something in a contractual, environment? If you have to value it, if you have to, put it into your books, into your accounting, what are the chances? What's the return? What is a verifiable, objective, quantifiable, audit proof, you want to show the auditors what is an audit proof type, calculation or methodology. And you can do all these. This is inventory management for, selling parts for cars. This is the automotive aftermarket. And the automotive aftermarket is saying, anytime that you drive a car outside of a lot, after you bought a car, the car by definition is used. It's a used car. It's no longer new. Maybe new to you, but it's no longer. And so if you don't have any insurance or any coverage on there that you purchase directly from the dealer, by definition, you are in the aftermarket, the automotive aftermarket. You buy a new tire, set of tires, you buy a spark plug or whatever, it's an aftermarket. So the aftermarket is humongous. It's hundreds of billions of dollars a year revenue, globally. And so which of these parts do you manufacture? A lot of parts are very different. So it's inventory optimization. To say, car type A, family type B, or specific, make and model, which ones of these do you actually manufacture? If you over manufacture something, guess what? You have holding costs, you have cost of obsolescence, the technology becomes obsolete, nobody uses it. You have holding costs, inventory costs, and you have potentially, loss of sales. You could have made B more, and there's not enough of B, there's too much demand, and you made way too much A. So, how do you balance the manufacturing across these things? You can even do it for, things like parking spots. We did a whole parking analysis for Saudi Aramco. Saudi Aramco, I would say one of the most expensive or most profitable, I wouldn't say profitable, the highest revenue, one of the highest revenue companies in the world that's privately held. It's, one shareholder is the king of Saudi Arabia. What they wanted to do is open up a brand new museum, if you will, that tries to rival the Smithsonian in Washington, D.C., and to rival, the Louvre in Paris. And so they wanted to spend billions literally on this. And one of the areas that they were struggling with was parking space. They wanted to create parking garages with fancy, trains that will take them from this garage about a mile away that goes downtown and then goes into this building. They want to figure out how many, parking spots there will be. Do you execute it? Do you, things like that could be done. And so they can actually figure out how many parking spots do we need. This is waiting time, the probability of number of people actually showing up. Okay, if you have 1,400 parking spots in this case, 51% of them will have to wait. People will actually show up. The average wait time is 46 minutes based on the simulation that we did, collecting data from comparable places like the Louvre. If you have 3,700 parking spots, which is what we recommended, less than 13% of them have to wait, and the wait time is less than 2 minutes, which includes driving up the area, the building, if you will. So you can apply it to parking lots, Department of Defense, public accounting, anything. Here's Johnson & Johnson, biotechnology. In biotech, you've got preclinical, you've got all these different phases that you go to prior to launch. These are sequential compound options. So in sequences, you cannot test things on human trials unless you've tested it on rats, and all the rats survive. If the rats die, I'm sorry, you really can't do anything at that point. So it's a sequential piece that you go through prior to launch, and there's a probability of all these things occurring. You can model that in here. In Oracle, we actually help them with banks where we look at asset liability management, where we actually look at the impact of embedded options. Insurance company where you're immunizing your risk, your upside and downside risk. So asset and liability, money coming in, money going out, and you need to balance that because you're extremely sensitive to perturbations in the economy like interest rates or inflation and so forth. So how do you immunize that? How do you find guarantees? How do you put in embedded options where you have futures, forwards, options that actually minimizes your risk? We did it. We've done a lot of work for government. Here's an example for the state of California. I'll show you a few more quick slides. I know I'm coming short on time. State of California, this was for Governor Schwarzenegger. We call him the Governator, Terminator and Governor. So many years ago, about 9 years ago, we were looking at the negotiation for the Governator for the state of California and oil and gas mining negotiations on Vandenberg Air Force Base, which was Southern California. And so it was a negotiation in terms of, profitability, sharing the oil gas, lease environment, and what is the percentage. We created models that were able to say, it's a sliding scale and how we would go about, doing that type of analysis by predicting, prices, productivity, production of the oil, the quality of the oil, all those different things. You can apply it to financial accounting standards. So stock market analysis, marketable securities. We have advised the FASB in the United States, the Financial Accounting Standards Board, on how to do modeling on some of these weird, instruments, if you will. And these weird instruments, we would use like stochastic processes, fancy words that you can use at 2 o'clock in the morning in a bar and hopefully not get, kicked out. Well, I guess in the UK, we don't call it a bar, we call it a pub. Forecasting volatility, okay, looking at all these various different things, Seagate, there's a whole slew of applications that we can actually apply, even for banking as well. So I know there was like a few people here actually in the banking industry. So credit risk, market risk, operational, liquidity, Basel III, Basel IV, extreme value theory, stress testing, value at risk, all these different things. We've applied it to a bunch of different banks in the past. And there are also case studies in case you're interested, please look those case studies up. And what we try to do is using our methodology, at least in the certification program, and of course in the certification, we do things a lot slower than what I'm trying to do now in, 60 minutes or so. We do go into, a lot of these examples and is, let's all click here, let's all click there, and let's actually make sure everybody learns this stuff. We make the assumption that, the basic, as long as you know how to add, subtract, multiply, life is good, and everything else will teach you how to be able to do. So one of the things that we do also in that session would be, Basel type environment. So at least you understand what historical simulation is, what is value at risk. All these are requirements from, so put it this way, our methodologies are not standalone as in we just make them up, or we just put a hodgepodge of methods and then we just stick it in the pot and say good luck. There is a rhyme and reason across everything. And the approach that we use, we look at COSO environments, we look at ISO 31000, we look at Basel Accords, we look at all these various, organizations like Financial Accounting Standards Board. So there are standards out there globally. What some of these standards do, for example, in Basel and also in, like, for example, the ISO 31000 says you must do this, but it doesn't tell you how to do it. We just pick the ball up and we say, we show you this is how you would approach it. Same thing with like Basel III, Basel IV. It says value at risk models, or you must run a simulation. It doesn't really tell you how to actually build a simulation model, but we actually take it from there. So all the methodologies are based on, type of, a lot of these different respects or global, strategies and global requirements that exist out there. Okay, and I just received a little message that just popped up and says, I've got about 1 minute before they kill me on the session. So hopefully I've covered this sufficiently, and I do apologize, because I'm cutting into your Q&A session, but we are always available to answer questions. Just feel free to send us an email. Life is good. Or just go to, realoptionsvaluation.com. Deidre and whoever else at IRM would love to hear from you guys. If you think this is something that may or may not be of interest to all of you, hopefully it is. Now, one last thing I want to leave you with is, there's a lot of material here, clearly. And in the courses and materials that we do, we do a lot slower and there's a lot more detail, more hands-on. Okay, so it's not as scary as what we're doing today, first of all. And secondarily, think of Microsoft PowerPoint or Excel. Everybody uses Excel or Word. Chances are I would consider myself a power user, and probably most of you are. But I would say on a good day, I probably use 10%, if not 15% of the power of Excel. Okay, does that mean that I stop learning at that point? The answer is no. You keep pushing the envelope. And so they have a tool set that is all available here. Pushing the envelope from the qualitative, which you already do anyway, which do not change what is tried and true. But what I'm saying is push it a little bit. Push the envelope and do the quantitative piece. And I have approximately 18 seconds before my time is up. So I just want to say thank you for your time. And I do apologize I cut into your Q&A. We are available at any time, and the video will be, automatically uploaded if you need to see anything going forward. So thanks again, and ciao from